So good morning. Again we have to continue our class in subject physics. In the previous class we have started the alternating current and electromagnetic induction. First we have to finish the electromagnetic induction, and I have given the variation how the EMF can be induced. So I have given the formula in the previous class. E is equal to E naught sin omega t. So what is the value of E naught? E naught is nothing but NBA omega. That means peak value. What is the meaning of peak value? Peak value means maximum value. The maximum value of EMF NBA omega. This why I am stressed one or two times. The most of the NEET examination, the problem was calculate the maximum value of EMF, from which the frequency also can be calculated. So be careful. The E naught value very important. What is the value of E naught? NBA omega. What is called omega? Here it is called angular frequency. Omega is called angular frequency. 2 pi nu. From which nu can be calculated. That is the thing you have to understand it. Induced EMF is sinusoidal because sin omega t. I got the sin omega t. It is a sinusoidal wave. It is a sine wave. So if it is along the x-axis, sinusoidal. If it is along y-axis, we know vertical. That is called cos theta. Here the sine angle. So the EMF 0, the EMF is maximum E naught. Again comes to 0, maximum in the negative side, again comes to 0. So this is called one cycle. Similarly it repeats. That is called alternating EMF. That EMF alternatingly varies. This is called alternating EMF. So be careful. Very important thing. This is actually a generator rule. AC generator. So what is how the AC generator works? Works under the principle of this variation. That means whenever the orientation of the coil changes, EMF is induced. So it is the generator rule. So back EMF in DC motor. So now it is not in our syllabus, but we are having central syllabus. That may be question asked in the NEET examination. So even now the syllabus of the NEET combined effect. So if you are thorough on central syllabus, more than sufficient along with our topics. Back EMF not in our state board, but is in the syllabus given in the NEET. A motor is the reverse of generator. So first we have to understand it. In the previous classes, I have given the differences between motor, generator, engine. What is the difference? Something in motorcycle, we call that as engine. In mixie or grader, we call it as motor. If the current is or power is shut down, we require generator. What is the difference? Engine, I have given in the Carnot engine everything also. Here, the thermal energy or heat energy converted into mechanical work. That is called engine. In generator, what happened? The mechanical energy converted into electrical energy. In motor, electrical energy converted into mechanical energy. So, the reverse of generator. So, the first line I have given, a motor is the reverse of generator. It converts electrical energy into mechanical energy. As soon as the switch is on, what happens? It comes to motor, the electrical. Due to the electrical energy, what happens? The motor rotates. So if it rotates, that will give the energy into mechanical energy. As the coil rotates, the magnetic flux linked with it changes. Whenever the coil rotates, what happens? The magnetic flux linked with the coil changes, just like what we have seen, giving rise to an induced EMF. This EMF opposes the applied EMF. So we have to, you should not confuse yourself. There are two EMFs in motor. One is called induced EMF, another is called applied EMF. What is applied EMF? From the plug point we are giving some current externally, that is called applied EMF, due to the motion of the coil, that induces the EMF. There are two EMF. We are applying the EMF. So due to that EMF, the coil rotates. Because of the coil rotates, itself induces the EMF. Actually, it opposes. EMF opposes the applied EMF and hence called back EMF. Since it is opposing, this induced EMF are otherwise called as back EMF. If R is the resistance of the coil, then current is equal to, we know V by R, that is E minus EB by R. E applied EMF, EB back EMF. Because of induced EMF, it is always opposes, therefore in the opposite direction, E minus EB divided by R. Efficiency of a motor can be calculated. The symbol for efficiency, everything, we know eta, that is EB by E. What is called EB? Back EMF by applied EMF. To find the ratio. So how much EMF we are giving, how much EMF we are getting, that is called EB. If both are same, 1. The maximum efficiency of a motor, 1%, 10%. Is it possible? Definitely, the induced EMF always less than the applied EMF. Therefore, the efficiency always less than 1. That means 100% less than. That is the thing we have to understand. This additional point. Induced EMF in a metal rod moving in a magnetic field. So the induced EMF, first one in motor. Second one, induced EMF in a metal rod moving in a magnetic field. When a conducting rod moves in a magnetic field and the induced EMF is set up between the ends of the rod or motional EMF. If a rod of length L moves with a velocity V perpendicular to the field B, then the induced EMF BLV. We already discussed that. What is a straight conductor carrying the current? There the force, here the EMF. BLV, that means area changes. If the rod is rotated with the angular velocity omega, then the induced EMF is equal to half into B omega L square. Be careful. So omega is angular velocity. If it rotates, the angular velocity comes. If it is in linearly motion, the linear velocity comes. Everything we know. That is a formula for finding induced EMF when the coil moves in a magnetic field. That is BLV. What is induced EMF? If the coil rotates, as if a rod, given rod, rotates with the angular velocity omega, then E is equal to half B omega L square. BLV half B omega L square. We have to keep this formula in our mind. The next topic is called eddy current. So eddy current actually given by the scientist Foucault. Other it is also called Foucault current. What is the meaning of eddy? Anybody knows? EDDY eddy. Some students are simply writing without knowing eddy. The eddy current was invented by the scientist Eddy. Is it right or wrong? That is a wrong concept, you know. Because eddy, what is the meaning of eddy? The eddy means hurricane or whirlpool. What is a whirlpool? So we are having whirlpool company. We are getting an washing machine, whirlpool. That is not whirlpool, it is a whirlpool. What is the meaning of whirlpool? Why they are putting the name whirlpool? Even on the motorcycle, we are getting the name Honda Unicorn. What is the meaning of unicorn? Corn means, we know, if any animal getting single corn, that is called unicorn. Just like in the motorcycle, we are having single shock observer. So that effect is very strong as rhinoceros. So that the way I am saying this, by name of this way, we are getting everything. So, the eddy current, what happened? The Foucault current, actually, any metal disc placed in a varying magnetic field, the current produced in the form of eddies. Eddies means not in the straight way. It find in the form of like that. so it in the rotating way, so that the strong metal piece gets oscillate in between the field, magnetic field. Automatically, whenever there is a metal plate placed in the magnetic field, whether it is required or not, immediately the current produced in the form of circle, or in the form of hurricane, or in the form of cyclone, or in the form of whirlpool, then the current is called eddy current. That is actually given in the paragraph. When a metal body is moved in a magnetic field in such a way that the flux through it changes, or it's placed in a changing magnetic field, the induced current circulate through the volume. So that I have done any metal piece placed in a varying magnetic field, the induced current not in the form of actual direction, the current in the form of circular through the volume of the body called eddy current. As the resistance is small, eddy current is large, and the metal gets heated up. Source of power loss in iron covered devices such as dynamos, motors, transformers, effect can be reduced by laminating the core. So if you are directly using the wire, instead of using the direct wire, if it is coated with or laminated core, we can minimize the eddy current, but we cannot eliminate. But sometimes these eddy currents are very much useful for us. In the furnace, we require heat. That is the point here noted that. So because the resistance is less, more current is flowing, heat is produced. That heat may be utilized in the furnace. The eddy current also used in the galvanometer damping. You know, galvanometer is an instrument to measure the current. If the needle goes, due to the inertia, it goes and shut down. So we have to keep the needle in a particular reading, which keeps the needle. Eddy current keeps the needle. And also in speedometer cable, you know, motorcycle, how much speed the motorcycle is going, or how much speed the motorcycle attains, can be calculated by speedometer. Actually, if you go by 60 km speed or 70 km speed, automatically the needle goes and rests on 60 or 70. So which actually make rest, the eddy current makes. So you know the wire which is connected to the front wheel. In olden stage it is connected to the back wheel. Nowadays everything is rotation in the front, it is connected to the front wire. So that when the wheel rotates, there is a magnetic field changes. The change in magnetic field produces a current, that the current is called eddy current. So these are the applications. So many applications are having eddy current. Sometimes we can have the eddy current, or sometimes we won't bother about the eddy current, but we cannot eliminate. We can minimize the eddy current. How can you minimize the eddy current? By using laminated core. Application. So that I have an induction furnace, deadbeat galvanometer, magnetic brakes. Sometimes the speed, the bullet train, all other trains are which has such a fast train, immediately the brake is applied, the body comes to rest. That is also due to eddy current. What happened? The wheels are magnetic wheel. They are operating in the superconductors. What is superconductor? We have discussed in the second unit thoroughly. Am I correct? When the temperature of the body decreases, resistance also decreases. For a particular temperature, the resistance becomes zero. The body on such a stage is called superconductors. If the superconductors, the current flowing through is maximum. Therefore, the magnetic field produced also maximum. Therefore, the rotation of the wheel in the opposing magnetic field. When the brake is applied, what happens? The change in magnetic field, the metal plate is placed. Automatically, the eddy current is produced. The eddy current rotates in the form of rotation. This rotating eddy current in the opposite direction of the wheel. Therefore, the body comes to rest. Next topic we can pass on to what is called the inductance. So just now we have seen inductance. So we have seen the inductance. The induction or inductance, both are same. Inductance. What is self-induction? Self-induction means the induced EMF in a single coil. If I take a coil, the current flowing through the coil is I ampere. Whenever the current flowing through the coil, automatically it induces the magnetic field. Everyone knows. So here I take a single coil. In the single coil I send a electric current. Because of that current, what happens? Magnetic flux linked with the coil changes. So here everyone knows the current produced changes the magnetic flux. Therefore, magnetic flux produced to the current are phi is equal to L into I. What is called L? L is a constant known as coefficient of self-induction. The coefficient of self-inductance is a proportionality constant. So we know by Lenz's law E is equal to minus d phi by dt. That is equal to minus d by dt of Li. So I take L constant minus L di by dt. This is the value of EMF. So be careful. If you understand this final solution, that may be make use all the applications. Therefore, induced EMF is nothing but minus L di by dt. L is called coefficient of self-inductance. How can I define this? So keeping L here, minus E by di by dt. So if di by dt is equal to 1 unit, then L is equal to minus E. What does it mean? The coefficient of self-inductance is nothing but an opposing EMF. Why put the word opposing? Opposing means minus value. So the coefficient of self-inductance can be defined as an opposing EMF when the rate of change of current is unity, or 1 ampere current is flowing for 1 second. The unit of L is always Henry. So this is actually happening given in the chart. Here phi proportional to I, phi is equal to Li, coefficient of self-inductance unit Henry. Self-induced EMF is equal to minus d phi by dt. This is because of Lenz's law. That is L into di by dt. That is given in this. The inductance of a long solenoid. That is a thing. So if you are taking a short solenoid, just I have seen what is an inductance of a long solenoid or a toroid. I already told you that what is a thing. If I take any wire, so in a straight bond, this is called the wire. If the wire wound like that, so this is called coil. So simply wire. The wire rotates, called coil. If the coil current flowing, that become solenoid. The coil, if I send a current, the solenoid itself rotated like that or arranged like that, then it is called toroid. So toroid, solenoid, coil as well as the wire, all are same. If a simple without any wound, wire. If it is wound, coil. In the coil current flows, solenoid. The solenoid itself arranged as one toroid. So the induced inductance of a long solenoid or a toroid, L is equal to mu naught n squared Ai. Be careful, that is a value mu naught n squared Ai or mu naught n squared capital A by L. What is L? Length mu naught Ni A square or mu naught n squared A into L. So we have to find the difference between the small n and the capital N. Be careful, that's what I want to explain now. Small n is the number of turns per meter. That means number of turns per unit length. Capital N, number of turns. What is the meaning of this? Number of turns and number of turns per unit length. For example, the coil length is 12 meter. In the whole 12 meter, how many coils are there? So count it, 25 coils are there. In 12 meter wire, there are 24 coils. Let it be 24 coils are there. Then 24 is called capital N. What is the number of turns per unit length? 24 by 12, that is equal to 2. For 1 meter, how much coil? 2 will be there. This 2 is called capital. Small n, big N. Number of turns per unit length. A area of cross section of the coil, L is the length of the coil. This is the thing we have to understand it. What is the coefficient of self-inductance of a long solenoid? Ordinary single coil is equal to minus L di by dt. If it is a long solenoid, L is equal to mu naught N squared A into I. This is an important thing we have to understand as far as the self-inductance is concerned. So you have to keep your mind. Mu naught N squared A by L. Next, this is another additional point to be noted here, DC circuit. So we are not having a DC circuit, but sometimes some question is asked DC circuit. Everything we are having only AC, the thing itself is AC. If it is in DC, DC means direct current. There are unidirectional current, the current only in the positive peak alone. If any inductor and a resistor connected in the DC circuit as shown in the figure, this is a EMF given E, the circuit A, C, B. This is the switches, a resistor of resistance R, the inductor of coefficient of self-inductance L connected as shown in the diagram. What happens here? Growth of current. Switch is connected across AC. So we have to, so kindly refer the diagram. So we have to connect like that, AC. If we connect AC and EMF minus L di by dt is induced in the inductor which opposes the rise of current. We know already the opposes the cause. The loop equation is E minus L di by dt, that's equal to IR. So IR is called voltage. Here the induced EMF across, if AC means the connection between A and C terminal, we have to subtract because opposing direction, E minus L d by dt. This is induced EMF, this is applied EMF. So just like our motor, so be careful. So switch is on, we are applying the EMF, applied EMF. Due to the current flowing through the coil rotates. When it rotates, it itself produces the EMF. That EMF is called induced EMF. Here also, we are applying a EMF from a battery. Just go through the circuit, E is the applied EMF. Then because of the applied EMF, the induced EMF in the coil minus L di by dt. That is equal to IR. So IR means if it current flowing through it, the resistor. Resistor is called R. R is included. If A connected to C, we know I current flowing through the resistor, I into R, that will give EMF. By solving these two, minus L d by dt and E minus L d by dt, R I is equal to E by R. So you have to keep I. This R comes E by R into 1 minus E power R divided by L, Ri by L. Current grows exponentially. This is the thing I have to hear. Just like where N is equal to N naught E power minus lambda T. We are going to see detail on the nuclear physics. Just like that here also, the growth of current E by R into 1 minus E power RT by L. Current grows exponentially. Why it is called exponentially growth? The current, whenever the time increases, the current going on decreases, but never it reaches a zero because it will take a long time. So that we are having the exponential curve. What is time constant? Time constant tau is equal to L by R is called time constant. Therefore, I is equal to E by R into 1 minus e power minus 1, that is equal to 0.63 e by R. So we have to convert it into exponential into logarithm value. The log 10 can be converted into. So this is a derivation, we need to bother about it. The time constant value tau is equal to L by R. So if you are when tau is equal to Z, what happened? E by R 1 minus e power minus 1 0.63 e by R. So this is only formula. This is the exponential curve. This is a current E by R 0.37 e by R. Then half-life, mean life, the same thing. The time constant of an LR circuit is the time taken by the current to rise to 0.63 of its final value. What is a time constant? Time constant is nothing but in the LR DC circuit, the time taken by the current to rise 0.63 of its final value. So this is a graph I have given. This is a graph L dI by dt plus IR is equal to 0. This is a differential equation by solving I is equal to E by R into e power minus RT by L. So this is simply I have given for application level, that's all. This shows that current decreases exponentially to 0 when stored in an inductor. The current decreases exponentially. That is the point I want to stress here. Least bother about the answers. What is the concept here? The current decreases to 0. Sometime the question is asked, how much time it takes to 0? We cannot find, but never comes to 0. So that the entire equation is switch over to exponential equation. What is the purpose of converting into exponential equation? The exponential curve. What is the advantage of exponential curve? We can escape from the answer. It may take infinite time to come to 0. What is an energy of Li squared? Of Li squared, energy in a magnetic form. When the battery is disconnected, the inductor becomes a seat of EMF and converts this stored magnetic energy into electrical energy. So that is a DC. And so the battery is even the battery is removed. What happened? The stored magnetic energy again converted into electrical energy. That is a concept here. Then LC circuit. What is called the LC circuit? This is also an interesting thing. LC circuit. The LC circuit, very important. We have to understand here. It may be very much utilized in the electronics also. L means inductor and a capacitor. If an inductor of inductance value L and a capacitor of capacitance C connected in parallel is called LC circuit, or the circuit otherwise called as tank circuit, TANK, tank circuit. What is tank circuit? Any inductor or capacitor connected in parallel, then the circuit is called tank circuit. So here, this is our inductor and capacitor connected in parallel. Potential difference? Q by C. How it comes Q by C? We know in the first unit itself, the current flowing through the conductor directly proportional to potential difference. In order to remove the proportional sign, we have to add one constant. That constant is equal to CV. Therefore, V is equal to Q by C. From this, we can able to find out the potential difference. V is equal to Q by C. Charge by capacitance, that will give. Potential difference equal to Q by C. That is minus L di by dt. We already given EMF induced in the single coil is there. Minus L d by dt. Since I is equal to dq by dt. What is I? Rate of change of charge will give the current. Therefore, d squared q by dt squared plus omega squared q is equal to 0. Differential equation. By solving this, omega can be 1 by root of LC. That is a thing we have to understand it. The angular frequency omega is equal to 1 by root LC, don't forget it. This is called angular frequency. So once we know the inductance value L and the capacitor value C, the omega, the angular frequency can be calculated by using the formula 1 by root of LC. From the linear frequency also calculated. How? Because omega is equal to 2 pi by T. That's 2 pi by T, nothing but 2 pi nu is equal to 1 by root LC. Therefore, nu is equal to 1 by 2 pi root LC. That is harmonically with the frequency. Thus, the charge on the capacitor will oscillate simple harmonically with the frequency 1 by 2 pi root of LC. That is called electrical oscillator. These are all things very much applicable in electronics. We are producing oscillator. How the transistor become an oscillator. There are different kind of oscillator. Oscillator is an instrument used to produce oscillation. Heartbeat oscillator, Hartley oscillator, tuned plate oscillator. Like that, everything we have seen. We will be seen detail about the oscillator in the electronic chapter. And that point, the inductor and the capacitor which are connected in parallel, automatically it gives the frequency nu is equal to 1 by 2 pi root of LC. This is the formula for the determination of frequency. Frequency is equal to 1 by 2 pi root LC. Where L and C value knows, substitute this, oscillator may be calculated. So this is the thing I want to stress. We need to bother about this. Simply we have to find out the value of omega. Omega is equal to 1 by root LC. From which the harmonic frequency nu is equal to 1 by 2 pi root of LC. That is the thing we have to understand it. What is mutual inductance? So similarly, I have given the thing, the mutual inductance. How can possible? If I take a coil, the coil which is connected to a battery and a key, another coil very close to this connected to a galvanometer. What happened? This coil which is in the battery is called the primary. The coil nearer with a galvanometer is called secondary. What happened? Here switch is opened or closed quickly. What happened? There is a magnetic flux linked to the primary coil changes. Because of that, induces in the secondary. What happened? Whenever the switch on and switched on, the current flowing through the primary is called IP. IP is called current flowing through the primary. Because of the current changes, it induces the magnetic flux linked with the primary changes. This induces the magnetic flux in the secondary. Because of it changes, it produces the EMF. That is the thing. So, this is the chain process. If the switch is closed permanently, no IP comes. Because of no IP, no phi P. Because of no phi P, no phi S is there. What does it mean? Here, the magnetic flux linked with the secondary always directly proportional to the current through the primary. We least bypass this phi P. We least bother about phi P. That is the thing we have to understand it. Or this phi S is equal to some constant M into IP, where M is called coefficient of mutual induction. This M is called coefficient of mutual induction. So from Lenz's law, E is equal to minus d phi s by dt. So this is called induced EMF in the secondary. That is equal to minus M dIP by dt. So from which M can be calculated as minus ES divided by dIP by dt. So this is called coefficient of mutual inductance. Just like we have seen self-inductance, like that we can calculate the coefficient of mutual induction. The coefficient of mutual induction is also equal to the opposing EMF of the secondary when the rate of change of primary current changes with the unity. That is the thing we have to understand it. So these are all the things I have given in the chart itself. So first we have to understand about the self-inductance. We have seen about the mutual inductance and everything. Next class we are going to see about what are the application of mutual inductance in the solenoid and the alternating current. So this is the best place to stop. Thank you.